Would anybody like to make a motion to approve the agenda?
I move approval of the agenda.
Motion's been made,
Second.
seconded. All in favor say aye.
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 Opposed, nay. Carries. And next we have the minutes from August 27.
Move approval of the minutes.
Second.
Motion's been made and seconded. All in favor say aye.
Aye.
Opposed, nay. Carries. That takes us to the consent agenda where we have comp plans and comprehensive sewer plans from the City of Crystal, City of Greenwood, City of Woodland, City of North St. Paul. Is there a motion related to the consent agenda?
I move approval.
Second.
Motion's been made and seconded. All in favor say aye.
Aye.
Opposed, nay. Carries. That takes us to the non-consent business agenda where we don't have anything at this time, but we do have three items on our information agenda. First one is the 2018 Water Resources River Report. Come on down. Welcome.
Thank you. Mr. Chair and committee members, thank you for your time. My name is Eric Herberg. I'm an environmental scientist here at the Water Resources Group of Environmental Services. And my colleague, Tom Wang, sitting back there, we are going to present to you today about the river report, which we published in 2018, and a little bit of overview of our river monitoring program that we have here at the council. So just to kind of set the stage and give you a little bit more context, 2 weeks ago in front of you was our manager, Judy Sventek, and she gave you an overview of our water resources program and what we do. So I copied over 2 of her slides just as a refresher to give you some context. So we are in the business of providing leadership and information to ensure clean, healthy, and sustainable resources, water resources for the region. And one of the ways we do that is through our surface water monitoring programs. And this is a map of our network from 2017. And we have quite a few monitoring sites of lakes, rivers, and streams. And the data from that goes to support quite a few different functions, which are listed on the slide. I won't read them off because you saw this 2 weeks ago, but just kind of setting that context. So we are going to dive into our river monitoring program and take a closer look at that. The modern version of our monitoring program dates back to 1976. We actually have data from before that going back to about the 20s, but the digital comparable version is back to 1976. We monitor on 5 different rivers. The majority of that is on the Mississippi, St. Croix, and Minnesota, but we do have a couple sites on the Rum and the Vermilion. In total, there are 22 monitoring sites. 6 of them have auto monitoring equipment, which means it's continuously monitoring and we don't have to go up to the field to actually pick up the water samples to bring back to the lab. And we monitor for quite a few different parameters. So we have our conventional things like total phosphorus, nitrate, basically nutrients, and chloride, things like that. But then we also have some toxics and metals that we monitor for, some organic pollutants, and also some biological samples. So we're very data rich, and that's something that's really unique about this agency is that we have a lot of data, so it's really fun to play with as a data scientist. So we were kind of thinking, what can we do? What stories can we pick out of this? And that's what brought us to this report, which we published last year. And it's titled The Regional Assessment of River Water Quality in the Twin Cities Metropolitan Area. And we were looking at data from 1976 to 2015. So we will now dive into some of the results from that report. So we decided to focus on the 3 major rivers that are coming through the metro area. That is the Minnesota, the Upper Mississippi, and the St. Croix. And it's important to keep in mind that these rivers, before they even come through the metro area, flow through a lot of upstream areas. So for the Minnesota River, we kind of have this whole southern Minnesota watershed. The Upper Mississippi is kind of central Minnesota. And then the St. Croix goes over into Wisconsin as well. So those things, those watersheds and what's going on has an impact of the water quality of the rivers before they even come to the metro area. So one of the things that can impact water quality in the watersheds is land cover. That's one of the big ones. And when you look at this map of the land cover in the watersheds, what you might notice is that there's a lot of tan in the Minnesota River watershed. So that's this one here. And that tan represents agriculture. So that's different than when you look at the other two watersheds. We have quite a bit more green and purple, and those are kind of wetlands and forests. So there's more natural areas in our other two watersheds. There are other characteristics which can impact water quality. Land cover is not the only one, but it is one of the big ones. So I just wanted to highlight that. So for this report, we picked 10 monitoring sites on our rivers to take a look at with the data, and they're on this map here. So we have 6 along the Mississippi River, and then there's 2 along the Minnesota and 2 along the St. Croix. And we picked these kind of to be upstream and downstream from wastewater treatment plants or the entrance and exits from the metro area, just to get a representation of what's going on. And what we actually did in our full report, we took a look at 15 different parameters, so quite a few. I'm not going to go over all of them, just a few quick highlights today. So we looked at flow, so basically how much water is in the river. We also looked at total phosphorus and nitrate, and these are both nutrients. If you have too many nutrients in your water, it can cause issues because the nutrients cause excessive algae growth. And when that algae dies off, it decomposes and lowers the oxygen. And that is harmful for the aquatic habitat. It's bad for recreation. It's just unpleasant all around. And then this also links up into the problems that Lake Pepin and the Gulf of Mexico with the dead zone is having. So it's all kind of connected with that story. And then we also have chloride, which is basically a salt. So you hear it a lot in terms of road salt. And the same with chloride, if you have too much of it, it becomes toxic to aquatic organisms. So it's not great for the environment. What we actually did in our study was kind of a twofold assessment. The first was to look at medians to kind of see the general patterns and recent conditions with the data, basically to see how the sites compared to one another, how the rivers compared to one another. And I will just point out that a median is slightly different than an average or a mean. So a median is basically the most typical value you have in your data set. So if you were to line up your data from the lowest value to the highest value and pick the one directly in the middle, that's your median, because we are interested in seeing kind of the most typical value in the data set. And then the second part of our study was to look at statistical trends and to see how things have changed over time. And that part Hong is going to talk about in just a couple minutes. All right, so I'm going to jump into some of our kind of recent conditions, and I'll break down the slides so you have an idea of what's going on. It's kind of complicated at first. But this is an example of looking at medians per site. So on this map here, we have one bubble representing one of our river monitoring sites. And what we did is we took the most recent 10 years of data that we had at the time, so that was 2006 to 2015, and we calculated the median for that site and then plotted it on this map. So the bubbles that you see, the size of it corresponds to the size of the median. So if you have a bigger bubble, if you have a bigger median, smaller bubble, smaller median. It gives you kind of a quick snapshot of how the sites compare with one another's from the last 10 years. So it's like a snapshot of recent conditions, essentially. So here we have flow. You can see that as the Mississippi moves along through the metro area, the flows are increasing. And you get this big jump where the Minnesota River enters here, and there's also a bigger jump between these two sites where the St. Croix River enters. So that's how these kind of maps are. This is a story that these maps can kind of tell you. So moving on to our first parameter is total phosphorus. Again, this is a type of nutrient. And total phosphorus, the first thing I will say about this map is that you might notice there's red lines on the rivers. That indicates that there is an impairment related to total phosphorus, and the impairment is something that's defined by the Minnesota Pollution Control Agency, identifying that there's too much phosphorus, it's causing issues, and there's then an action plan in place to address it. But when we're looking at the bubbles, there are a few patterns that stick out. Kind of the biggest one is we see a difference between the rivers. So we have these larger medians along the Minnesota River. And upstream, we know that the Minnesota River watershed is more agricultural, and it is more susceptible to erosion geologically than the other two river watersheds. And that is things that can contribute to total phosphorus in your water. So it's not so much of a surprise that we're seeing these higher total phosphorus concentrations in the Minnesota compared to the other rivers. On the other hand, in the St. Croix, we see some of our smaller values of total phosphorus. The St. Croix River watershed is more forested, it has more natural lands, so it just will have less total phosphorus as a result. It doesn't have as many agricultural fields as some of the other watersheds.
And yet, Mr. Herberg, it's designated as impaired, the St. Croix, as it gets closer to the Twin Cities.
Yep. So thank you for the question, Mr. Chair.
Yeah.
So that, I believe, is because of it's technically evaluated as part of Lake St. Croix. So it has a few different standards related to total phosphorus when you're talking about impairments. I unfortunately don't know all the details, so I'm not the best person to answer that question for you. But
Thank you.
all right, so moving on, now we have nitrate. So we see what nitrate is doing in our rivers in the metro area. And you might notice right away that we kind of have the same pattern with these larger medians in the Minnesota River. Studies have shown that croplands are a major source of nitrate in Minnesota surface waters. So again, it's not much of a surprise that we're seeing these higher nitrate values in the river that runs through a lot of agricultural areas. And then again, vice versa, over here we have these lower medians in the St. Croix, the watershed that's more forested. What I also will point out on this map is that we can kind of see an impact from some of our wastewater treatment plants. So if you look here, this is our Metro wastewater treatment plant here in St. Paul. It's the largest one we have. And it falls between these two sites, and we do see a slight increase along this stretch of the river. And that's because we know we have some nitrate in our effluent. And this is because we have ammonia in our wastewater, and we need to get rid of it. And the way you get rid of it is by transferring it into nitrate, which is then exits through the effluent. So we know that we have nitrate coming out of our effluents into the rivers. Of course, it's not the only factor. There's many other factors from other sources, but I just wanted to point that out for you. All right, and then the last slide that I'm going to talk about before handing it over to Hong is chloride. And again, this is, you can think of it as salt, basically. So a main source is road salt. So near urban areas, you tend to have more salt use with parking lots and roads and whatnot. So we do see these higher medians kind of closer to the urban core. You might also notice that we still have this larger median in the Minnesota compared to like the other two rivers here where they enter. There's a lot of research going into that in terms of chloride sources across the state. Kind of the running theory right now is that some chloride has, or some fertilizers have chloride in it. Mm-hmm. So again, we have a more agricultural watershed. So that could be at play here. But what also is interesting is downstream of our larger wastewater treatment plants is where you see a bump in chloride in the rivers. So again, we have our Metro plant here. We also on the Minnesota have Seneca and Blue Lake. And so we see these kind of increases upstream and downstream from these wastewater treatment plants. What's going on here is that there is chloride in the wastewater before it even gets to the plant. So this is from sources such as water softener or commercial industry applications. And our wastewater treatment plants are not equipped to remove chloride. It's something that's very expensive and very cost prohibitive to do so. So the chloride essentially just goes straight through our wastewater treatment plants and into the rivers. So that's why we're seeing this kind of bump downstream from our larger wastewater treatment plants. All right, so now I will wrap up this kind of general patterns, and we're going to transition into looking how things have changed over the past 40 years. And I will hand it off to Hong to take over from here.
Thank you, Eric.
Welcome to the committee.
Okay. Okay. Mr. Chair and council member, thank you for me to today have an opportunity to present my result. And as Eric said, my name is Hong Wang, Principal Environmental Scientist. And because limitation of my language, I try to speak slowly. If you have not clear, just interrupt me. Feel free. So, and thanks Eric already talked about background about our group and our background about our river report study, and also talk about what's current condition of water quality. My job, my portion is talk about historical change. So people always like history. So this is why I'm also feel very excited to talk about history, about water quality. So when talk about the historical change, and we need to review what's happened in the last 100 and 150 years, century, what's major events related to the water quality. So as you know, in the 150 years ago, in the late 19th century and early 20th century, we have industrialization make huge, very quick expansion of urban and also fast growth of population. Those growth of population urban increase results in a lot of waste. So in that time, unfortunately, we don't have a wastewater treatment facility. So the sewer directly discharge the river. As you see the first photo, say in that time we have a very bad situation and a very smell. If you go to river smell, and if you can see the sewer floating in the river, and we have very low oxygen, and this almost kill fish population. And also we have a very high level of bacteria. And all this caused public health issue. In addition, as you see in the earlier 20th century, we have agriculture expansion because we use fertilizer. Fertilizer in he said in the Minnesota River Basin caused a lot of erosion. This brought a lot of sediment and nutrients. This also contributed to our regional river a big issue. So to fight this public issue, and to fight the public health, we have Metropolitan Waste Control Commission, and actually now it's part of Metropolitan Council, built our first Metropolitan Metro Plan in 1938. And later on, we continued to build several plans. And then meanwhile, in 1966, we have an advanced technology applied to improve and the treatment of efficiency. In 1984 and 2000, we have a much advanced technology called denitrification and biophosphorus removal technology. This significantly improved the water treatment efficiency and reduced discharge of wastewater to our river. And most important, in the federal level, we have our president signed a Clean Water Act in 1972. So what does it mean, Clean Water Act? Actually, if you don't know, if you have some people already know, but Clean Water Act actually we call it, very popular term we call it TMDL. This maximum daily pollution loads. So this means any water body assessed is not reach your water standards, you need to list as impaired, report Federal Environmental Protection Agency. Then you need to program to do a TMDL study. This means you need to identify what is pollution address parameters, what is pollution source. Then allocate this pollution load to individual source. Then the local authority or city or like county need to do BM best management practice to invest money to control the source. So this is about 10-year cycle. This is contribute a big issue to improve the non-point source. So as you say, we all Miss Council we're doing this is point source to reduce points. But this program control non-point source. This means for agriculture, from the surface runoff. And also another big event in our history is and the separation of fire and the sewer system. Before sewer was combined flow into sewer. Stormwater combined with flow to our wastewater treatment plant. But if we have a wet year storm event, this water will overflow directly to the river without treat. This causes a lot of problem. But the Miss Council really did a great job to separate this stormwater and the sewer in 1985. So all this, of course, we need to spend a large amount, huge money. So now we need to understand, does this huge money invest, we use taxpayers' money, does this improve the water quality? Oops, sorry. So this is why my study is to try to answer a few questions. Is this is the water quality already changed for what our investment during the last 40 years? So if change, is this change improved or declined water quality? And also what is contributed to this change? And also another important question is, do we have still any current water issue and what we need to improve? So all this information will provide for our decision maker for decision maker like you committee member. So what is trend? Actually, trend, like I said, I give you this is actually one of my results, and just show you what this looks like. And like you say, we started from the beginning to end is about 40 years, and this background dot is monitoring data. So we use USGS advanced technology statistical model to calculate the model trend. The green line actually is trend change, the concentration we calculate. As you see for this result, a concentration reduced continuously over the last 40 years. This means reduced concentration means improved water quality. So because this report we have been did this report for the last few years, a huge report in Wisconsin, a lot of information. So because today we have limited time, so what I can do is just talk about a few examples, give you some idea of what is change of water quality. So as you see this map, same as Eric did, and I use a triangle. He used a bubble, I use triangle. So the triangle down means what concentration reduced, and up means up. Reduced means improved water quality, up means decline water quality. And now I give example of total phosphorus. Total phosphorus, of course, is a major water quality parameters because this contributes a lot to our water quality, including the lake pipeline pollution and all downstream like Gulf of Mexico. So all contribute to this total phosphorus. This is an important index for us to understand. And as you see, for the metro area, across whole region, 3 major rivers, water quality in terms of total phosphorus improved. So declined significantly. And give you some idea, I also including some like a trend line for you to understand what looks like a change. This actually is over last 40 years result. But the number here, the percentage change, we just use overall change from the beginning to end. What's changed for this one? Give us some idea. So based on the number, and we can see across region we have improved water quality significantly, including Mississippi River and the St. Croix Minnesota River. St. Croix River have a less improvement, but I need to point out this does not mean significant improvement means we have good water quality, because as you say, the average result for this Mississippi River and Minnesota River have a large bubble, and the St. Croix River small bubble. Because this is why, and we have a significant change because you have a lot of room to improve. And also another information I want you know is in the flow-in location, we also have a large improvement. This means huge watershed in this area. This means improvements indicators not in the metro area, but across the region and across the whole watershed improve. So what contributes to improvement? Of course, and first is metro statewide we have phosphorus ban, not allowed to use phosphorus, and also TMDL, as I mentioned, non-pollutant source, and best management practices our investment to control pollution source. And lastly, I want to talk about treatment biological phosphorus removal. This biological phosphorus removal is advanced technology. Wisconsin invests a lot, and for this result, I can show you, as you say, we have 2 Metropolitan plant here, another plant here. But if you compare the downstream, upstream, we have a large and improved decline of water quality. This means really contributed by our improvement of wastewater treatment plant by our investment. So to give you more detailed idea, I give you 2 figures. First figure, and as first one is concentration we measured and discharged at our Metropolitan wastewater treatment plant. So we have biological phosphorus technology biological phosphorus removal technology applied in the 2000. And later on, we continue to apply this to different process, different plants. So from the beginning, as you say, when I applied to until almost finished, we change our treatment facility. We have a large decrease of concentration discharge to river. So this decrease about 90% removed. This means we reduce 90%. And also all in the metro area, we have a 7 wastewater treatment plant. And this 7 wastewater treatment plant, the total also like this is actually this figure is concentrated, but this figure is low. This means how many tons per year we reduced from beginning like 1,200 reduce about like 250. So reduce about 90% or so. This means this council contribute a lot to regional improvements in terms of point source. And the second,
Can I ask a question on phosphorus? Is my recollection correct that it sticks around in the water or in the muck, and then it kind of comes back? So even though it's been banned for many years, you still see it in the water. That's one reason why you still see phosphorus in the water.
Mr. Chair and Council member, this is a good question. The question is because the phosphorus already banned for so many years, but still why the phosphorus still there? Actually, it's a very good question. This is my PhD study. I study in internal loading of phosphorus power store in the sediments. So the phosphorus is actually additional information. Phosphorus is very strong absorption to sediments. So when you apply the phosphorus in the land or flow to river or the river, this is going to abandon with sediment, deposit sediments. But this is a very complicated process by the physical chemical process. If we have overnight water have oxygen higher, this band is very strong, will stay there. But as soon as we have a very bad water quality, concentration of oxygen reduced, become oxidation form become reduced form. This means bonding is gone. The phosphorus will release. This is how it happens in a lake, especially when you have deep lake. The deep mix in the top is okay, but deep is no mix. This means no oxygen. That's why continue recycling. This is why this is what we call the phosphorus recycle, and even you deposit and release them by algae or by some and die when they die, the deposit in sediment. So most stay there. The good question, but anyway, and now we'll try to do say the control the source. At least we do not add more, and also we use the point source like most council we did. And this is a good question, improved water quality. But next we have a not good question, nitrate-nitrogen. So this nitrate-nitrogen because used widely by user for fertilizing in agriculture. So we have a regional and regionally we have a results show increase of the nitrate for the region. Like you say, most increase is the Mississippi River, and less increase is Minnesota River, and St. Croix River also increased a few. And again, I want to point out, it's not increase does not mean the water quality is good. Like the bubble, like I said, the Minnesota River is a big bubble because agriculture contributes. The increase means because you have a relative number, this relative increase number to compare with beginning to end. So it does not mean have a low concentration. So, and also same as the increase like the beginning and flow in, and this agriculture relatively stable, a little bit increase. And St. Croix River, because forest areas is much less increase. So this is bad news for us, but since we have investments, I like to say we have good news. If you take a look at my study, not to say overall concentration, take a look at each trend line, you will see reduce, increase slow, and even shows start reduce. But sunlight increase very fast, but increase slow. And also say a lot of increase very fast and flat. So this means our work, our control is work to control at least because this nitrate is historical problem. As you see in the earlier 20th century, we use a lot of fertilizer. So this caused a lot of problem, but we made this will work. So this and the reason to increase during the last 40 years, of course, population increase, agriculture and industrial activities.
And I believe if we could interrupt for 1 second, we have a question from a council member.
Mr. Chair, perfectly timed. Mr. Wing, this is fabulous. I love this presentation that both of you are giving, and I'm really grateful for the spotlight being shown on the agricultural activities. And the good news is that there are some really concerted efforts going on to address those, and I hope and will do everything I can to help make sure they're successful. I'm concerned in particular about the industrial activities. And in particular, I'm going to kind of wade into your district a little bit. Councilmember Fredson, there's been a lot of conversation about the redevelopment of the Ford plant property over in Highland Park. And the bulk of the attention has been on the surface and what's going to happen in terms of housing and transportation and all of those issues. But buried deep in that property is a lot of very toxic waste that the Ford company and others buried there over the years. And there are a number of organizations and entities that are very concerned about the leaching that has and will continue to go on unless it's addressed, and addressed while there's hopefully someone there to help pay for it. I'm concerned because it feels as though up and down the corridor, the Minrick corridor, there appear to be a number of vacant buildings. And I'm wondering if there's been an assessment as to how much industrial waste is sitting there leaching or waiting to leach into the river and add additional problems. Are there inventories done on those properties on a regular basis? Do you know?
Yes, actually, this is a very good question. And now, because we have a source, mostly now we know the source is Metropolitan discharge because the Metropolitan take from each household your toilet flush, the waste, and also another in the urban areas septic system. Because nitrate is different from phosphorus. Phosphorus, I said, is bent to soil sediments. So apply the soil, just apply the soil. But nitrate, when you apply or septic system leak, the water will go with water direct go to ground, so not attach to sediment, will flow to the river. So and so far, with council, we don't have any information yet to do the inventory, but I believe MPCA could be, Judy could be answer this question too.
Well, Mr. Chair, council member, I don't know if I can exactly answer your question, but there is information on the landfill Superfund sites, and they keep information on closed sites like that and have some of that information. We are not tracking that, but it is something that as we see development occurring, we should be able to track changes over time, and at that point we can investigate if there's any relation to some of that.
Thank you. Thank you both.
Okay. So also like agriculture expansion of the livestock and meat supplies also contribute because a lot of waste, dairy and cow, so including surface runoff contribute a lot of nitrate during go to flow. So this actually nitrate is a big challenge for us because we fight for a half century, still we can't say approved, but still high concentration, as you say, the average bubble size is still high. So it's challenging for us. But the story is not finished. We have another big challenge. So chloride, like Eric said, chloride have a big bubble in the Minnesota rivers and also Mississippi River. So for my train, when I started last, we don't have 40 years data, but at least we have about 20 or 30 years data. Indicates no hesitate, chloride continue increase for last 20 or 30 years. So the reason because we salt use, and in winter when in the metro area we use salt for de-icing. This is a public safety issue, and also and the wastewater treatment plant discharge. This we cannot do anything for wastewater treatment plant because it's so expensive to remove this from wastewater. So salt used for salt water softener goes through a sewer, pass through to the river. This is also another second contributor to our increase of river. Because if we have population increase, that's of course salt use will be increased. But we have many methods. Like my home, I never use the salt. I use this water softener, but I use kind of technology and maintenance free without use any salt back flashing. So this means this is challenge for us. And also fertilizer use is big challenge for us. Like you say, Minnesota River, even the increase money because increase not a big number, but background concentration really high. It's last half century already use a fertilizer. So contribute a lot of this for Minnesota River. So, and also livestock waste, septic system, human waste, and contributed by the groundwater too. So I like to say most people say this is a salt issue is in a metro area, of course increased by a lot of number. But if you say the flow in this area, also this means watershed down metro area also contribute a lot of the issue. So this is actually is a big issue for us, and we have been working on PCA. PCA also use all this information to address metropolitan area was control or management practice. And so I think for this to address this issue, we have follow-up study. Now I'm working on propose another study to do a major tributary chloride trend analysis, try to identify what is in the metro area, which tributary contribute the most into the metro area. This is what one of my study going on. And so this is what I just use limited time give you 3 parameters to give you a basic idea. Basically, of course we have a concentration goal reduced and increased, improved, or mixed trend. We have 3 types. And this conclusion actually based on our study whole report, not on my slides. So based on this one, it's good, very good news because we have a major. We studied 9 parameters for at 10 sites in the metro area. We found a major parameter improved, significantly improved, including sediment and phosphorus. Bacteria, what I mean is big issue before, and biological oxygen oxygen demand. This actually is organic pollutants and also ammonia. So I think most improved. This means we did a good job in the metro area in the region. So we need to say okay, but I need to mention this improvement not by individual department, but for the whole region, for state. So this means I like to say together we make change, we improve water quality. And existing, and I'm sorry I need to mention here, this is actually imagine stuff. It's not imagine, so my typo, so I'm excuse my. So anyway, existing and emerging issues. This nitrate is a historical problem, but chloride is a big issue for us, new challenge for us. And also mixed strain for chloride-free. Chloride-free actually is algae. It's growing in the water. If you have more nutrients, this will grow to make water quality bad. So if you want more information, you can go to Met Council website. I like to say, I'm very proud to say, after we publish a report, we attract a lot of attention in the region, in the state, in the countrywide. We got invited to deliver a presentation by different location, and also, our result is being republished by the federal, like a National Park Service. So it's really, I'm proud to say, as a Met Council member, we demonstrate our leadership, critical role in the region. So that's all. Thank you for if you have questions. Welcome.
Questions from the committee?
I just want to make a comment,
Please.
Mr. Chair. Thank you. this is amazing. I know that the council has been a partner with a lot of organizations. I happen to be involved with one of those organizations, and this is great work, and it's making a difference. I know the university has some major initiatives dealing with the agricultural issue. And if you've never seen it, there's an amazing photograph of the confluence of the Mississippi and the Minnesota that will almost make you weep because it is so vivid, the amount of pollution that happens at the confluence. So I would like to suggest that we think about how we can take what we know and maybe work with cities and townships and counties to help provide information for those of us who are everyday users of products that contribute to these challenges so that we can make changes in how we live. I don't want to get into a paper straw versus a plastic straw kind of accusation back and forth. I want it to be really, and I personally am reducing plastic straws, but I don't want this to become a political nightmare for the Met Council or for cities or the rest of the entities. But I am always kind of anxious about having realistic, doable things that we can do at home, as well as within the ag industry and the other entities that contribute to the challenge. So to the extent that we can help be a part of that with other units of government, I think it would be a good move.
Yeah, Mr. Chair and the council member, I think this is a very, very good suggestion. This is why I'm working for this too. And sorry, I'm now a member for my 30 and committee member. I try to volunteer to do most address issues in chloride, what I'm addressed because and education, like you said, is very important. Like people we just discussed with our manager, the people apply the salt, how much you applied, when you smart use salt, and also your practice your clean your driveway, everything. This I think is a very good suggestion. Thank you.
Yeah, please, question.
Thank you, Mr. Chair. I'm really interested in this study that you're talking about on the tributaries. Do you have any idea how long it'll be until that information is ready? Because that'll give us a lot more granular information about where the pollutants are coming from.
So that means the chloride, right? The salt. Yeah, and now we're working on this, and we start to test because now USGS have new model. We have applied a new model to try to apply this. I think going to finish by the end of this year, beginning of this year. We're going to do the fact sheet for individual strain to identify what the source was changed. Some may be a change. I did a few. One, two is not changed too much, but most is significant increase. This contribute to a review too. So.
Mr. Chair, council member, I'd like to add that, so we did a stream trends report similar to this report about 5 years ago. So what we're doing now is just adding chlorides for more information. So, and at some point we'll be updating that as well to get more information.
Thank you.
And this report came out last year, is that right?
Last July.
And what was the reception? I imagine we sent it out to a number of stakeholders. Can you tell us a little bit about what they had to say, either local governments or nonprofits that are interested in this topic?
Yeah, like my last presentation, I said, we after we published the report, we got a lot of requests for presentation, and also like present in the upper Mississippi River in the 5 states, and by federal alien of this Mississippi River. So we also have a request by the National Park Service to publish our result. We have our result being used by the county. We invite to present by the Sacred River Association and also by county. And also we invite by the USEP and MPCA to presentation. They use our result for the Lake Pepin and also use our result for the metro area chloride salt management plan. And the most important now, because for the nutrients reduction strategy about 40 years, 20 years, 40 years reduction strategy. Now they are middle 5 years. They use our results, indicate what improvement, because they want to do an update of what progress they made. We just finished a task request by MPCA months ago to extend our load and our trend from because we just finished until 2015, we extend to 2018 because match their time schedule time frame. So I think so quite often it's very interesting. We also present our results to a local water conference and publish our result in the National Monitoring Network newsletter. So a lot. So I cannot remember. I don't know if you can. But this is really good job. So I think.
Fantastic. Question?
Thank you. Not a question, just a comment. Cities have been working pretty hard on reducing their salt loads by pre-treating the salt that goes on the road so it sticks to the road and you don't have to use as much. It sounds like we probably need a little bit more public education for homeowners about water softeners.
And salt as well, when they're throwing salt on their sidewalks or driveway. I think my understanding is they oftentimes put on way too much than it's like, this amount of salt will take care of a driveway, no problem, or a good chunk of the sidewalk. But people feel like they need to just have it, an inch thick to make sure. Please.
Mr. Chair, I want to second that. I buy what is labeled as an environmentally safe salt. I have no idea if it's environmentally safe. They say it's good for pets and the environment, so I figure, well, my dog and my...
Probably not a toxic, I think.
Yeah. The other thing that I think we really need to kind of focus in on is the fertilizers. I live in a townhome complex, and regularly when I take the cute dog out for a walk, there'll be little signs saying not to let children or dogs play in the grass. And I always think, okay, so we don't want the children or the dogs, but what happens when it goes down into our ponds and streams in our neighborhood? It's pretty freaky. So.
And we can't have children play in the grass?
Not while that
That's
product
not
is
great.
first on there.
I don't want to live there.
No. Fortunately, we don't have many, if any, kids. We've just got a lot of dogs. But it's just that, we're using so much without even thinking about it. So my apologies for babbling.
And I use one of those metal straws, by the way. That's reusable and reusable.
Yes.
So, there you go. Any other questions or comments? Thank you very much. Very informative. Great work.
Okay, thanks.
Great.
And that takes us to the second item on our information portion of our agenda, the 2018 Water Resources Lake Monitoring Report. So we're going from rivers and streams to lakes. Here we go.
All right.
Welcome.
Thank you, Mr. Chair. Mr. Chair and committee members, thank you for having me. I'm Brian Johnson. I'm a senior environmental scientist in the Water Resources section, environmental quality assurance, the same group with Hong and Eric and Judy. And I'm following up on the similar things that they've been talking about, but this talk will be focus on the lakes and the lake monitoring program here at the council. The Metropolitan Council's lake monitoring program started back in 1980. So this year, after we finish up the monitoring season 2019, will be completion of the 40th year of monitoring. So it's been around for a while. The lake monitoring program first started off as monitoring done by staff here at the council, and then it also incorporated a volunteer program later on. And but either way, whether it's a staff collected data or volunteer collected data, the purpose is to provide water quality information and data to help determine regional lake water quality conditions, and also help look at water quality trends in those lakes. This information helps the council and the local units of government to target lake management efforts, and also to evaluate those efforts to see how effective that they are. The data we also or the data that we collect also is sent to the Pollution Control Agency, Minnesota Pollution Control Agency, to use for their purposes in evaluating lakes, whether they're meeting water quality standards or not, and then they can use those to list the lake if it's impaired or not. Impaired meaning that it doesn't meet water quality standards. The lake monitoring program has three components to it, and as I mentioned, the program started in 1980, and that started off with monitoring done by Metropolitan Council staff. And that continued like that all the way up through 1992. Then 1993, the council started up the Citizens Assisted Monitoring Program, and we lovingly call that the CAMP. And that is a citizen science-based program. Volunteers are recruited to monitor lakes throughout the 7-county metro area. And so that greatly expanded the amount of lakes that the council could monitor in a particular year. Just relying on staff is we just didn't have enough staff to cover the 7-county area in a given year. And then since then, out of the citizens, or the CAMP, we also started recently a more formal identification, what we call the Professional Citizens Assisted Monitoring Program. And this is where we are getting help from professional staff from our local partners, typically local units of government. A little more detail what the CAMP is. Again, that's citizen scientists, volunteers that are recruited from local communities, and we get help from that mainly through what we call our sponsors, which are local units of government, such as cities and counties, watershed districts, and things, entities of that nature. They recruit the volunteers. We train them. The council trains them, and they go out and monitor their lakes. And they provide scientifically valid data. And what I mean by that is that there's some critiques out there that citizen scientist-based programs don't generate valid data because they're just volunteers. But we have a robust quality control program that we ensure that they do collect scientifically valid data. And so I want to make that clear, and that's one of the well-known aspects of our program regionally. The picture here shows a volunteer. He's out in his paddle boat, and he's measuring water quality, or about to, and he's using what's called a Secchi disc, this thing right here, and he puts that in the water, and seeing how far that goes down the water until you can no longer see it gives an idea of the clarity of the water. So that's just one thing that they measure, and I'll get that I'll give more detail on that. The ProCAMP, professional organization partners, that kind of came out of the CAMP, where some of our sponsors could not find enough volunteers, so they have professional staff start stepping in, and so now we have a separate kind of unit tracking. So the Washington Conservation District examples in our ProCAMP program. Now the staff monitoring program, we go into more detail with we get into more monitoring effort. Some things we monitor for monitor parameters for excessive nutrient enrichment, such as phosphorus and nitrogen. We also monitor for chloride, road salts, things that were talked about in the river program. And we look at water clarity, which is measured, what I showed you before, the Secchi disc. And then also looking at temperature, how acid or alkaline the lake is, all that pH, the dissolved oxygen, how salty the water is. One is we use conductivity to measure that, it's a fancy term, and then the cloudiness, how cloudy the water is, and we call it turbidity. We also, with the saltiness, that's a general measure of the water quality. But we also look at chloride specifically, because that's an emerging concern due to roadside applications and whatnot. And so chloride can be in high enough concentrations, can be toxic to fish. So that's what's pretty important about it. So this is what the staff lake or the staff lake monitoring program generally looks at. Now the CAMP program generally focuses on excessive nutrient enrichment, nitrogen, phosphorus, water clarity, and temperature. That's the main. Those are the main parameters they focus on. So they do a smaller suite of parameters. The ProCAMP program can basically go after the same parameters that we're looking at the council staff monitoring program. Just a quick overview on the amount of lakes that we're talking about here. 2018, we monitored a total of 184 lakes in the monitoring program. 180 of those were through the CAMP program. And then we have more lake sites than lakes because some lakes we have more sites on it. For example, Forest Lake, we have 3 sites on it. Medicine Lake, we have 2. But most lakes we have one main site, which is typically over the deepest part of the lake or in the central part of the lake. And we're focusing on the open water quality. So we're not near shore typically. We're out in the middle of the lake. And so that's one important thing we want to make or get across. But one of the main things that's been monitored throughout the course of the program, all the way back to 1980, is a focus on nutrient enrichment, or more appropriately, like nutrient over-enrichment. This is also called eutrophication, and it's a concern for the lakes in the region, throughout the state. It's a concern for the country. It's even concern. It's a worldwide concern, actually. And in this is that the lakes get enriched with these nutrients such as phosphorus and nitrogen. And for lakes, particularly in upper west Minnesota, Twin Cities area, phosphorus is the main constituent that's driving this over-enrichment of lakes. What this enrichment does is phosphorus is a nutrient and makes plants grow, it makes crops grow better, it makes house plants grow better, grass grow better, and it makes algae and plants in the lakes grow better. And this phosphorus is coming from off the landscape. Typically, it's runoff from soils that have eroded from landscapes, such as through poor agricultural practices or stream erosion, construction sites. This phosphorus is attached to particles on the roadway from oils that drip off cars, that making tires eroding, rubbing on the pavement, maybe the tires. Can come from people's lawns. Grass clippings get blown into the street. Leaves that aren't picked up and fall into the roadway and washed off through runoff from the rain into storm sewers and into the lakes. And then once that material gets into the lakes, adding the phosphorus, the stuff decomposes, releasing phosphorus, and then encouraging the growth of algae plants. And this growth of algae then, on this graphic, we have a phosphorus here. As that goes up, that increases the amount of algae in water. And when we measure algae in water, we use chlorophyll. It's just the pigment plants it causes, or that enables their growth. So as this algal mass increases, water clarity decreases, and then that creates an aesthetic problem. It also creates problems where the more algae in the water, the less clear it is, less amount of light can penetrate into the water. It becomes more opaque, becomes more turbid, cloudy. With that, then that can affect the growth of plants in the lake, which can then affect fish habitat, negatively affecting fish habitat. So then once this algae and then maybe along shore this increased plant growth, this grows, it's eventually going to die. It dies and it falls to the bottom and it starts decomposing, rotting, consuming oxygen, and then that creates problems with not enough oxygen for other living things. So you have fish kills, depletion of beneficial organisms, insects and whatnot that live in the sediment. So it's detrimental to the lake ecology. and it affects aesthetics, recreational use, and changes the ecology of the lake. So that's kind of what this nutrient enrichment involves, and it's a problem in the Twin Cities metro area. So we like to track it and see what conditions are like, and are for particular lakes, are they improving, are they degrading, or are they staying the same? So I've been tracking this information since 1980 for many of the lakes. And I just want to show you on here on this picture on the top, we have a picture of a Secchi disc. This is from Chubb Lake. This is a lake down in southern Dakota County. And this picture up here on the top, that's was measured in May, early spring. And that disc is at 20 centimeters below the water surface, so about that deep down. Then come August, we went out there, this is our August measurement right here. The disc is still at 20 centimeters, but you can not see it very well. So that's what typically happens, is that throughout the summer, we get degrading water quality. And this, so you got more algae in the water, it's greener, and the water clear is worse. Here's another way of looking at this information. Again, this is looking at our nutrient eutrophication, nutrient enrichment information. This is for a lake, Medicine Lake in Plymouth. And the site we're looking at right here, it's our southwest site, right down there. And it might seem a weird spot to put a site, it's a big lake, but that's the deepest point of the lake. And we also have another site up over here. It's more mid-basin. But I just want to show you this, just the variability or where we put our sites. But I just think this is interesting. The deep site is in this bay. But this graph, or both of these graphs, show over the course of one monitoring season, so generally April through October. And this green line on the top graph is showing you the amount of algae in the water. And here it starts off lower in the spring. We do get a little bump here during the early part of the year. This is an algae bloom. It's a type of algae called diatoms. They die off, and the water then has less chlorophyll or less algae in it. As you can see, the water clarity. Now this is just to clear up. These axes are reversed. So here we got chlorophyll, and it increases as you go this way. Water clarity, or Secchi depth that we call it, it's a measure of water clarity. This is going down. So the water clarity is increasing as we go down. I just want to point that out. So as the amount of chlorophyll decreases, we see an increase in water clarity. As the chlorophyll increases, we see a decrease in the water clarity. Okay, so this is what it looks like over the course of the season. And then down in this lower graph, we have phosphorus, and it kind of generally increases as the summer goes on. And the reason for that is that over the course of the year, we have rainfall events falling onto the surface, creating runoff, capturing all the material on roads and the lawns and streets and construction sites and what have you, running off of fields that don't have the best management practices in place. And also internal affects this throughout the season. Mr. Chair, you had a question earlier, talk about how does phosphorus that's currently in the sediment, can that re-suspend and get into the lake? And yes, that does happen. It's called internal loading. And sometimes, depending on the lake, some lakes, the internal loading of phosphorus is actually a bigger problem than what's coming in from the landscape. So it is a very important issue to deal with, and that's just one factor that it's taken into consideration when developing like a lake management plan or something like that. Okay, so I just want to show you here what a typical data looks like for a lake for a given year. Now, what we do with this information is that we have generally two ways of communicating our data and our information out to the public and to our local partners, and that's through two reports. We put them out every year. We have a lake water quality summary report, and we also have a large annual lake report. The summary report is 3 pages, and I believe it's linked on to your information there on your iPads. And as part of that 3-page report, we have a map, and it's this lake grades map. That's page 3 of the report. And we produce grades for each lake that we monitor every year. And that grade is based on those 3 parameters I showed you before: the phosphorus, the chlorophyll, or the amount of algae, and the secchi. What we do is we grade each parameter. So we'll grade a particular lake. They have an average phosphorus concentration over the summer of a certain value. We'll give that an A or a B or C, D or F. We'll do the same thing for the chlorophyll. We'll give it an A, B, C, D, or F. And that A, B, C, D, or F is a grade compared to a certain amount of lakes across the whole metro. So it's like a grading curve for a class, so to speak. Then the secchi depth, or the water clarity, grade that as well. So we get these three parameter grades. So we might, for a particular lake, we might have an A phosphorus grade, an A chlorophyll grade, and an A secchi grade. Well, we'll average those grades. We'll do a grade point average, essentially, and we'll give that grade point average, we call it a lake grade, lake water quality grade. So that lake would get an A. And that's what we're showing on this map here, are the lake water quality grades for each lake for 2018. So we got Medicine Lake down there. It's hard to see, but yeah, right there is Medicine Lake, Southwest Basin. My finger's too fat. So that's a green, so I got a C grade. Then the dark blues are A's and reds are F's. So that's page 3 in the water quality summary report. We put this out every year and post on our website. Now here's a table showing kind of a trends of these lake grades over time. This is in our big annual lake report, and that report's about 700 pages. And the reason why it's so big is because each lake has its own 3-page section. Got about 200 lake sites. That's 3 times 600 pages right there. But on one of these summaries for a particular lake, in this case it's Medicine Lake Site 1, which is at Southwest Bay again. We can look at the monitoring data over time. And back in 1983, we had a chlorophyll grade of C and a secchi grade of C. 1999, C again. 2010 C, 2007 C. So based on this, we can see over time for this particular lake site, it really hasn't changed much. Now this is a pretty crude way, or a more simpler way of assessing trends for a lake. So it's not as in depth as what the river monitoring report went into. We do this on an annual basis, so it's kind of a quick and simple way of looking at trends for a particular lake. So we show everything up there each year in our annual report. Now here's another lake. Here's another historical summary of grades for Demontreville Lake. This lake is located in the city of Lake Elmo. And you can see in 1980, it was getting C grades. Lake grade is C grades all around. And then you started seeing some B's over here. Now we're getting some A, got an A. And then 2008, we got some A's. And then 2017, it's up to A's. In this particular lake, we saw an improving trend. Well, it went from a C to an A lake, went from an average Twin Cities metro area lake to an A lake, which is an astounding improvement.
Mm-hmm.
And so that's the kind of information we can provide in our annual reports. and this is what we do every year. So here is, again, I just wanted to show you the cover pages of of the reports that we put out. This is the Lake Water Quality Summary Report. That's a 3-pager. And this report we put out every year. It's also, it's our report where we summarize the data for each individual lake. So this is this is about 700 pages or so. It's all electronic now. It used to be paper, so we saved a lot of trees in recent years by going electronic. Right now, we're still working on the 2018 report, and that should be done soon. And so I guess that's all I have to say about reporting at this time. I want to finish up on the what we have at the council are what's called council priority lakes, and these are lakes that have been prioritized based on several criteria.
Just a quick question, if I could interrupt for a second.
Yeah.
On the grades, I think you mentioned that they're kind of graded on a curve. So does that mean that a lake that got a C in 1980, that the water quality could be increasing over time, but could get a C in 2018 because of that curve, because all of the lakes have been increasing a little, or been getting a little bit better? You know what I mean? I don't know if I explained that real well, but
yes.
because you don't use like the same, you don't use the same numbers, or do you? Like, if you're using, are you using the exact same numbers in 1980 to get a C as the same numbers would get a C in 2018?
Yes, that's a good question. And what I mean by grading, the grading curve was established back in, I think, 1989. Now it's based on a set of lakes that the council monitored up until that point, from 1980 to 1988. We took data from that time period on, I think, around 100 lakes. I can't remember the exact number. And we established a grading curve. So we basically established, okay, how many of those lakes, let me put it this way, the lakes that got the best water quality, the top 10% of that population of lakes, we give them an A. Okay, and then the next 10% down, we gave them a B. Okay, so that's how we established this grading curve, similar to what a teacher would do. So that is the grading curve based on that data set from 1980 to 1988. And we've used that same grading curve throughout up until now, up through 2019. So the grading curve is static. That hasn't changed. So when we compare the lakes data now, it's compared to that data set. So,
okay, that's great. Thank you. Another question.
Mr. Chair, maybe you explained this and I missed it, very possible, but in northern Washington County, Oneika Lake isn't one of the lakes being monitored. In Ramsey County, Lake Phelan isn't one of the lakes being monitored. Are they being monitored by another entity, or are they just not on a list?
No, that's a good question. I'm going to go back to the map. You mentioned Oneika Lake.
I don't think Phelan.
So Oneika Lake, did you mention?
Yeah, it's up between.
Oneika Lake is part of our program. You'll see on here, it's up right here.
Oh, Phelan is on there. Okay.
That's part of our program. We have a volunteer on that. The sponsor is the Rice Creek Watershed District.
Oh, okay.
And it's got a insufficient data grade.
Okay.
And what that means is that we did not have enough data to calculate a lake grade.
Okay.
In that lake specifically, there is enough data to make a phosphorus grade and a chlorophyll grade. But we cannot get a water clarity measurement on there using a Secchi disc, because the water is either too clear, and we can see the Secchi disc on the bottom, or there's enough vegetation where the disc is blocked by the vegetation. We can't see the disc because of vegetation. So it doesn't mean we're not out there monitoring.
Okay.
So we do have data on that. So that gives insufficient data uh, result. Now to answer your next question, you'll see like Ramsey County here. You mentioned Lake Phalen.
Right.
That lake is monitored by Ramsey County,
Okay.
and they do most of the monitoring in Ramsey County. You see that a few lakes there are
Race
that
Creek.
we do in our CAMP program. That's because they fall within the district of Rice Creek Watershed District. We partner with them as a sponsor.
Mr. Chair.
Yes, please.
When say Ramsey County does their own monitoring or any other county, are they using the same metrics that the council does?
It can vary a little bit, but they look at the same parameters.
Okay.
So they're, Ramsey County measures for phosphorus, they measures water clarity using a Secchi disc. We do, our citizen volunteers use a different method of collecting the water.
Mm-hmm.
They use a jug,
Mm-hmm.
whereas professional people typically use what's called an integrated sampler, which is a long tube, about 6 feet long, that they measure the surface. So, but we've done some, way back when the volunteer program was being formulated, the council did some studies to compare those methods between what's typically used and what a volunteer would use, and they came up that they compared very well. So you also notice, just to address your question again, you'll notice that up here in Oakland County is not represented in our the council's monitoring program, except there's Pickerel Lake. We did Pickerel Lake in 2018. And the reason for that is the Anoka Conservation District does a lot of the monitoring up there in partnership with some of their watersheds. You'll see we have a lot of lakes that are not in this area. The Minnehaha Creek Watershed District has a very robust lake monitoring program. So we're not trying to like out monitor other people, because we don't want to step on other people's toes. It would be a duplication of government resources if if one entity is monitoring, you have another one doing it. So it's a way to avoid that duplication. And we, as part of the lake monitoring program, we keep in contact with these other organizations to see what lakes that they're monitoring, and so we don't duplicate those efforts. And that's important then when it comes to our priority lakes. These lakes, what we're focusing on here, at least with the monitoring through the council staff, is we focus on these priority lakes. And then we're also looking for our regional partners in the area, in the region like Conservation District, Minnehaha Creek, County, Ramsey County, Carver County. What priority lakes are they monitoring? And if they're not, then we can step in and fill in those gaps and get that information on our lakes. The CAMP program, on the other hand, they monitor, there's priority lakes in there as well, but they also monitor lakes beyond the priority lakes program, because in that instance, we're partnering with local units of government, and they have lakes in their area that's a priority to them. So we're there to help them get the information they need to help them meet their water management or their lake management goals and water resources policy plan, or their surface water management plans and things like that. So it helps complement their needs.
How many camp volunteers do we have?
In any given year, it typically is about 115 to 130 volunteers.
Great. Please.
Mr. Chair, Mr. Johnson, and to all of the staff, I have a nephew who, when he was in high school, had an opportunity to take a course where he learned about these types of environmental issues, and in particular wetlands. And to the extent that, well, to what extent are we able to reach in and help partner with schools and help provide resources for teachers and students, both at the K-12 level, but also the higher ed level? Because I think this is critical, and I just wish I had had something like this when I was back those ages.
Do you want to take a stab at that one, Mr. Johnson, or? Lisa or
Good, Mr. Chair,
whoever.
committee members, I'd love to. Actually, one, we have younger people involved.
Mm-hmm.
They're actually volunteers.
Mm-hmm.
They have to have permission from their parents. Um, but they've decided to commit to monitoring
Mm-hmm.
a particular lake from April through October, at
Mm-hmm.
least for the summer. One issue we're having, at least with schools, is that they're only in session, up until early June, and we're looking for a core amount of data from May through September at least, preferably April through October. But what that said is we have some lakes in our world that are monitored through nature centers, like Westwood Nature Center, St. Louis Park, and it's another one in, I'm drawing a blank. It's in Blaine, I believe. It's in the Chain of Lakes and Rice Lake.
Mm-hmm.
And so they have people there that we've trained, and then they bring students out,
Mm-hmm.
um, younger people that go out with them,
Mm-hmm.
and so they get experience doing this kind of thing.
Mr. Chair.
Please.
And additionally, what about in terms of opportunities for the council to be engaged in the classroom setting or to provide resources for the classroom setting, like some of this data or background? Does that occur very often?
Not particularly with classrooms, like this kind of information classrooms, other than access on the web, but we do outreach activities through like the Children's Water Festival,
Mm-hmm.
which is coming up, or Pollution Prevention Day in the city of Farmington.
Mm-hmm.
I believe the Children's Water Festival addresses fifth graders, and Pollution Prevention Day addresses fourth graders.
Mr. Chair, council member, so we do a lot of outreach. We have externship programs and things like that. I think we'll put together another presentation to have a whole conversation about that, if that would
Thanks.
be good. Okay.
That'd be great.
And what is the Children's Water Festival? You said it's coming up. It sounds like fun. We might want to go.
And the adult kids want to go.
Yeah, exactly.
So, Mr. Chair, council members, it's an event that's been happening every year for I think 21 years now. It's at the state fairgrounds. So there's about 600 to 800 kids come from across the metropolitan area. They go to different stations that are set up for them to learn about different aspects of water. We run a river station to kind of shows, and also talks about wetlands. And then we also have a watershed exhibit that we work on there. So, and anybody can go and see it. And I know we usually have the chair, I think, went last year, and we usually have some pictures taken and some staff there to take pictures of it. So we have about 20 staff that actually work there that day.
Wow. Yeah, keep us in the loop. I'd love to swing on by. I'm sure other council members would be interested in that as well. Is it open to the public, or do like schools send? It sounds like schools maybe
Sure.
send. their
Mr. Chair,
students
Councilmember,
there.
so schools actually have to put in their name to be on it. There's usually a waiting list, so it could take 3 years for a certain class or school to get in there. But yeah, it's very popular. So because the costs are defrayed, so the sponsors and things like that pay for their buses, and they get lunch and things like that. It's really a great experience for the students. So.
Wow.
And I think anyone can go. Well, not anyone, but if you're related to associated with the council, you'd be able to go and walk around and see the things going on. So.
Sure. Great. Another question? Yeah.
Through you, Chair, this might be a stupid question, but I'll ask it. What happens to chlorophyll, phosphorus, and nitrogen over the winter?
Well, Mr. Chair and council members, the chlorophyll, which is a proxy for the algae, during the wintertime, the temperatures cool off, so their metabolism slows, or they just simply die off. Ice covers the lake. There's less light penetrating into the lake, so the algae tends to die off, basically. And with that, what was in the water column with that algae settles to the bottom, so that phosphorus then might tend to settle to the bottom a little bit more, at least with the particulate phosphorus, and the water clarity tends to increase. For a typical lake, it depends on the lakes, but so you'll see in the spring after ice off, typically you'll see water tends to be clear because of things have a chance to settle, basically.
How about those other elements that Then, what else did you mention?
Well, you
Nitrogen.
mentioned
Nitrogen.
Yeah, nitrogen. Typically nitrates and nitrites. That's what we're like nitrates and nitrites. Those are parameters that we measure as well. But those in lakes typically are below detection, except for lakes that are highly impacted by agriculture, or lakes that are influenced by like an impoundment of a river that's formed by a dam. So those tend to stay low because aquatic organisms take up that type of nitrogen very readily. Um, the other form of nitrogen we look at is called total Kjeldahl nitrogen. That's a fancy word, but basically measures the amount of nitrogen that's coming from biological sources such as animal waste and organic nitrogen. That tends to be a little more stable in water column. So, but again, that would reduce over the winter as well compared to summer.
Thank you.
Thank you.
May I continue?
Yes, please, of
All
course.
right, thanks. I just want to get into council priority lakes. I have listed over here just what defines a priority lake, and one is regional recreational value. If a lake meets certain criteria such as size, it needs to be 100 acres or larger. It also needs to have public boat access, and also an adjoining park or public space on the lake, and that then is defined as a regional recreational value lake. That would then make it a priority lake. Also, good water quality. If it has good water quality, basically an A lake, is that good water clarity, low amount of chlorophyll, and lower amounts of phosphorus. If it meets that criteria, then it's good water quality. If it's a drinking water source, these are typically either defined in statute or such as the St. Paul region or St. Paul St. Paul Regional Water Services. If they have that lake used as a source of water, drinking water, then that would make it a priority lake. And another one is wildlife significance. This is if it has important attributes for wildlife, such as migratory waterfowl and things like that. So, with that, if you have any questions, additional questions, that'd be great. Also, down here, webpage, this accesses the lake monitoring assessment webpage, where we have links to reports and our environmental information management system where data can be had. There's also links to videos of some of our volunteers showing what they do. And then that also links to our Citizens Assisted Monitoring Program, which gives more information on that. Feel free to look at that again. Thank you for having me.
Thank you very much. Fascinating information, and I know that as this committee and this council looks to our strategic priorities in the months and years ahead, all of this information on our streams and rivers and lakes, I think will be very informative on how we decide to continue to tackle phosphates and nitrates and chlorine and all the other bad stuff out there that we want to keep out of our water. Very good. Any other questions for Mr. Johnson? I think we're good to go. All right, and that takes us to the general manager's report. Take it away.
Thank you, Chair Lindstrom. I have a couple quick items just to bring your attention to. We just sent out the customer communities, the rate charges for 2020. Just want to reassure you that there's no surprises, and if you get questions, don't hesitate to call Ned or Kyle. Because it is a little complicated in that when you talk about a percent increase, but then it's not exactly straight application because it's a percentage of their flow based on the actual billable year. So sometimes people get a little confused because they'll get the question, well, my increase was more than 3.6, but you've said your increase is 3.6. So it takes some good explanation sometimes. And We've been at this a while, so most of the community staff have got it pretty well under control, but you may get a question from an elected that's trying to figure that all out. So don't hesitate to call on us. We're happy to help. The other is just a project with a lot of public attention will be the work that's going to happen near the Minnehaha Falls area, those sewer improvements, because of the bike trails. It's a very popular area. So you probably got something in the mail, but we thought, because there was a recent question about NeoGov and how to get signed up, and that's a key piece for us to keep project updates. So we've got, I think I heard about 1,000 people already signed up to get project updates on this project. We sent out some information about a week ago about NeoGov and how that sign up works, but we're set up to demonstrate for you right now real quickly how, if you wanted to get set up for project reports on the Minnehaha, how you would do it. And then you have a handout with your materials today that would walk you through it on your own. So I'll turn it over to Susan.
Okay, thank you, Lisa. Mr. Chair, committee members, in front of you, you should have a handout that we prepared, and we are actually, I'm going to hopefully coordinate this with our AV person that's in the back to walk you through the actual sheet of paper that we prepared for you. So if you want to follow along with us, we've already gone to our external website, metrocouncil.org. Once you are there, you will navigate to wastewater and water at the top of the screen. And from there, you go to the left-hand side of the screen, you scroll down a little bit and you click on projects. From there, you click on sewer planning and construction updates. And in the middle of the screen, you'll see some blue bars, provided you don't have color inconsistencies. And this would apply to any city, any project that's going on within the system. For this one, we are going to Minnehaha, so that's in Minneapolis. You'll click on the M through R. And if you scroll down a little bit, the first one under Minneapolis is the Minnehaha Park project. So you'll click on that link. And it opens up the project page. And Jason, if you could keep scrolling down, you'll see that there's a wealth of information that's available here about the project. At the bottom of the screen, I believe there is some contact information, and this is for any project that we have out there. There's project update documents. I believe there's an overview document of what's going on with the project, so you can find all of that out there. And Jason, if you could scroll back up, on the right-hand side of the screen, you'll see a gray box. It says e-newsletter or text, right? Yep, right there. And so all you're going to do is you would either key in your email address or a cell phone number that has texting capability. And Jason's going to use mine for demonstration purposes. With our nice short email address. And then you would click on sign up. And that opens up this page. And Jason, if you could scroll down, what I want to show you is you can subscribe to any number of communications that are available to NeoGov subscribers. Our specific projects are under environmental services. And for this one, you'll see the sewer construction updates, and there should be one there for Minnehaha Park. If you scroll back up a little bit, Jason. Yep, so you would check mark that if that's the one you want. You can check mark all of them if you want, but then you'll probably get inundated with emails. And once you're done, you'd scroll down to the bottom and click on submit, and it will update and add you to that list. So with that, I will take any questions.
Can you sign up for all updates within your council district? I saw the numbers were down way at the bottom there. The district numbers?
I believe so. I'm not well versed with what is contained within those lists.
That'd be pretty slick.
So,
Any other questions? Any council member?
Thank you, Mr. Chair. Having been a web developer once upon a time and long time ago, that's not very user-friendly. There should be an option to just sign up for that one. And once you've successfully done that, say, would you like to sign up for this other big list? Because people get lost trying to scroll through all of those and find their way. So if there's any way we could fix that, that would be nice.
We'll take your feedback, and that's exactly why we thought it would be good if we demoed it. Because you would almost think at that first spot where you put your email in, since you'd already clicked the mini
You should be
aha,
done.
that you'd be done, but you're not.
You're right.
so Jason, can you go back to the main external website page? Just go to metrocouncil.org. We'll navigate off of this screen and go back to metrocouncil.org. Please. Yeah, just click on water and wastewater. And we'll see if it's there. Keep scrolling. It doesn't appear that it's there. Jason, if you could go to the projects and the sewer planning. Thank you. So there is on the right-hand side, when you get to this screen, there is a newsletter sign up. And let's look at the very bottom of the screen again. There might be one down there.
Yeah, there's some,
Down on the lower left
Yeah.
in the dark blue.
yeah, there is.
So that might get you the same place.
Yeah, all of those, it looks like, take you to that big, long list. And from a user standpoint, it would be much better to just subscribe somebody to what is ever on that page and then ask them, do you want to do these other ones?
We'll see what we can do. It's a good point. But at least on this particular project, there's been 1,000 people that have signed up so far.
So somebody's been able to figure it out.
Yeah, exactly. That's impressive.
And that concludes my report. Thanks for the feedback, and we'll see what we can do.
Very good. And that means we are adjourned. Thank you, everybody.